This video focuses on GH-300 scenario-based questions, specifically how GitHub Copilot works and handles data. We'll break down the logic. B.
Question 1 scenario: a developer is working in VS Code inside a private enterprise repository. While typing a function and a descriptive comment, GitHub Copilot generates a code suggestion. The organization wants to understand exactly how the suggestion was produced, especially which stages touch the developer's code, and which components enforce policy and safety rules. Which sequence most accurately represents the life cycle of this Copilot code suggestion? Correct answer: C. IDE prompt creation, proxy filtering, LLM proxy post-processing, IDE. Explanation: GitHub Copilot follows a multi-stage pipeline. The IDE gathers local context, cursor position, nearby code, comments. This context is assembled into a prompt. The prompt is sent to a proxy service which applies prerequest filters, policy, security. The LLM generates a response. The response passes back through the proxy, where post-processing filters, code matching, safety checks are applied. The final suggestion is returned to the IDE. Question 2: how Copilot gathers context scenario. A developer expects Copilot to use helper functions defined in another file of the same project. However, Copilot only references variables and functions near the current cursor location, even though the helper file is open in another tab. What is the most accurate explanation for this behavior? A. Copilot can only read one file per session. B. Copilot prioritizes cursor proximal context due to limited context windows. C. Copilot ignores uncommitted files. D. Copilot avoids crossfile references for security reasons. Correct answer: B. Explanation: Copilot gathers context using a limited context window. Because LLMs can only process a fixed number of tokens, Copilot prioritizes code closest to the cursor, nearby functions, comments, and surrounding logic. Even if other files are open, they may not fit into the context window. Question 3: prompt construction versus training data scenario. Copilot suggests a coding pattern commonly seen in open source projects, but adapts it to match local variable names and comments. A developer assumes Copilot is pulling code from GitHub. Question: which explanation best clarifies what is actually happening? A. Copilot searches GitHub repositories in real time. B. Copilot retrieves stored examples from its training set. C. Copilot uses learned patterns and adapts them using prompt context. D. Copilot clones similar repositories behind the scenes. Correct answer: C. Explanation: Copilot does not search GitHub or retrieve stored examples. Instead, the LLM learned patterns during training. The prompt injects local context names, comments. The model generates new code probabilistically based on both. Question 4: role of the proxy service scenario. An enterprise security team wants assurance that sensitive data is protected and that Copilot suggestions comply with licensing and policy rules. Question: which Copilot component is primarily responsible for enforcing these safeguards? A. The IDE extension. B. The large language model. C. The proxy service. D. The training pipeline. Correct answer: C.
Explanation: the proxy service is the security and compliance boundary. It filters prompts before reaching the LLM, applies policy and safety rules, detects near matches to known code, filters responses before returning them. Question 5: handling of private code. Scenario: a developer working in a private repository asks whether their code is stored or reused to train Copilot. Question: which statement best describes how Copilot handles this data? A. Private code is permanently stored for quality improvement. B. Private code is shared anonymously with other users. C. Private code is processed transiently and not used for training by default. D. Private code is encrypted and added to training data. Correct answer: C. Explanation: Copilot processes private code ephemerally, used only to generate the current suggestion, not stored permanently, not used for training by default. Question 6: code matching and licensing risk. Scenario: Copilot refuses to suggest a code block that is extremely similar to a known open source snippet. Question: why does this happen? A. The IDE blocks copyrighted content. B. The LLM avoids repetition by design. C. The proxy performs similarity detection to reduce IP risk. D. The training data excludes open source code. Correct answer, C. Explanation. Copilot includes code similarity detection in the proxy layer to reduce verbatim reproduction, lower licensing and IP risks, encourage original output. Question 7. Copilot chat versus code completion. Scenario. A developer notices that Copilot chat can explain entire files, while inline suggestions are short and fast. Question. What is the key reason for this difference? A. Chat uses a different LLM. B. Chat has access to live documentation. C. Chat uses structured, conversational prompts. D. Inline completion bypasses the proxy. Correct answer, C. Explanation. Copilot chat is designed for multi-turn conversation, explanation, refactoring, reasoning. Inline completion is optimized for low latency, small prompts, cursor-focused predictions. Question 8. Token limits and context loss. Scenario. In a very large file, Copilot ignores logic written earlier and produces irrelevant suggestions. Question. What is the root cause? A. File system limitations. B. Proxy timeouts. C. Token limits of the LLM. D. IDE memory pressure. Correct answer, C. Explanation. LLMs can only process a fixed number of tokens. When files exceed this, older parts are dropped. Cursor proximal context is prioritized. Question 9. Reasoning versus calculation. Scenario. Copilot accurately explains an algorithm but produces an incorrect numeric result when asked to calculate output. Question. Why is this expected behavior? A. Copilot avoids math by design. B. Proxy filters numeric output. C. LLMs reason probabilistically, not deterministically. D. Training data lacks math examples. Correct answer, C. Explanation. LLMs excel at language reasoning, are weak at exact arithmetic, predict likely answers rather than compute them. Question 10. How GitHub Copilot builds a prompt. Scenario. A developer notices that adding a detailed comment above a function significantly improves Copilot's suggestions, even though the actual code hasn't changed. Why does adding comments influence Copilot's suggestions so strongly? A. Comments are stored permanently by Copilot. B. Comments retrain the model in real time. C. Comments are included as part of the prompt sent to the LLM. D. Comments override the generated code. Correct answer, C. Explanation. Copilot builds prompts using code near the cursor, function signatures, developer-written comments. Comments provide intent and context, helping the model predict more relevant code. They are part of the prompt, not training data. If this video helped you better understand how GitHub Copilot works and how it handles data for the GH-300 exam, I hope it made the concepts clearer, not just the answers. If you found this content useful, please like the video, subscribe to the channel, and share it with others preparing for GH-300. Thanks for watching, and I'll see you in the next video.